Hi kids, I hope everybody is fine. So this video is for class 10 student. In class 10 we were discussing circles and we were solving sums from exercise 15.3 M L Aggarwal and we did till sum number 10. You can see the description box for the previous video. Now let us start from sum number 11. This was based on tangent and secant properties. In the figure, PQ is 24 cm, QR is 7 cm, angle PQR is 90 degree. Find the radius of the inscribed circle. There is a circle inside the triangle which touches the three sides of triangle PQR. And they have marked the radius as x over here. So we need to calculate x. First of all, in triangle PQR, that's a right angle triangle, which means PR is the hypotenuse. So hypotenuse square is equal to perpendicular square plus base square. So PR square is by Pythagoras theorem. Yes or no? So PR square is 24 square plus 7 square. That's 576 plus 49. So PR square is 625. Yes or no? So PR will be plus minus root 625. That's plus minus 25. We'll take the positive value because side cannot be negative. This is done. Okay, this is 25 centimeter. Now look carefully. What I'll do, this point I'll take it A and this is B, suppose. The point where the circle meets the side AQ. So AQ is the tangent at the point A and QR is a tangent at the point B. And this is suppose C. Look carefully. We'll join this. Okay. When you join this, if you look at the quadrilateral AOBQ, now this will be perpendicular, yes or no? The radius is perpendicular to the tangent at the point of contact. So OA is perpendicular to PQ. Now look carefully. So these two angles are 90. This is also, OB is also perpendicular to QR. So this is a square. Why? Because all the angles are 90 degree. Because if three angles are 90 degree, the fourth angle has to be 90 degree. And adjacent sides are equal. See? OA and OB are equal. OA equals to OB. And all angles are 90 degree. Which means it's a square. Quadrilateral AOBQ is a square. Just be careful. So this is x. This is x and this is x. AQ will be equal to BQ will be equal to x. Now look carefully. BQ is x. QR was 7. So what is BR? BR will be 7 minus x. 7 minus x. Similarly PA. Look carefully. What is PA? The entire was 24. So 24 minus x. PA is PQ minus AQ. So 24 minus x. So this is 24 minus x. This is 7 minus x. Now look carefully. Tangent property. If two tangents are drawn from an external point to a circle, then the length of the tangents are same, which means BR will be equal to CR. Yes or no? From the point R, we are drawing two tangents, RB and RC, they will be equal to. So this is 7 minus x. So this is 7 minus x. Similarly, PA will be equal to PC. Why? Tangent drawn from an external point. The equal length. So PA is 24 minus x. So this is 24 minus x. This portion is 24 minus x. Now PC is 24 minus x. CR is 7 minus x. And when you add these two, you will get 25. That is PR. Look carefully. PR is PC plus CR. Yes or no? PR we got it over here. That's 25. PC is 24 minus x. And CR is 7 minus x. So that's 25 equals to 24 plus 7. That's 31 minus 2x. 2x equals to 6. X equals to 3. Which means the radius of this circle is 3 centimeter. Very easy. We use the property that a tangent drawn from an external point, two tangents are drawn from an external point to a circle, they're equal in length. And we need to prove that AOBQ is a square. That was very important. All angles are 90 degree and adjacent sides are equal. Hence it becomes a square. Done? Chalo. We'll do the next part. Look at 11 part B. In the figure given, two concentric circles. You can see the smaller one and the larger one. They are concentric. They have the same common center. With center O are of radii 5 cm and 3 cm, which means the bigger radius is 5 cm and the smaller radius is 3 cm. From an external point P, tangents PA and PB are drawn to these circle. If AP is 12 cm, find BP. Find BP. Very easy. Look over here. First of all, this is the center. I'll join OA. Then OA will be perpendicular. Tangent at the point A. And from A, if you draw the radius, then the radius is perpendicular. Similarly, we'll join B, OB. So OA is perpendicular to PA. And over here OB is perpendicular to PB. Join OP. Now look carefully. In triangle AOP, AO is the radius of the bigger circle. This is 5 cm. This is 90 degree. So in triangle AOP, that's a right angle triangle. OP is the hypotenuse. So I can say OP square is AO square plus AP square by Pythagoras theorem. So OP square is AO. AO is how much? 5 square plus this is 12 square. That's 25 plus 144. That's 169. So OP will be plus minus root 169. That's plus minus 13. We'll take the positive value because negative not possible. So this is 13 centimeter. Done? We got OP. Now look at triangle OBP. Triangle OBP. Again, that's a right angle triangle because this is 90 degree. So this is my hypotenuse. OP is my hypotenuse. So OP square, Pythagoras theorem, is OB square plus BP square. Can I write? Yes. Put the value. 13 square is OB. OB is the smaller radius, which is 3. So instead of OB, I can put 3 square plus BP square. That's 169 equals to 9 plus BP square. So 169 minus 9 is 160 equals to BP square. So BP will be plus minus root 160. So BP will be, we'll take the positive value only. Okay. So root 160, I can write 4 into 10. Yes or no? Now BP is the square root of 4 is 2. The square root of 4 is 2 and root 10. So BP will be 4 root 10 centimeter. Done by Pythagoras theorem. In this triangle by Pythagoras theorem we got the hypotenuse. In this triangle with the Pythagoras theorem we got, yeah. And for this triangle it was the perpendicular. The hypotenuse was given. The hypotenuse of both the triangle is common. See? OP. Done. In this triangle, this is a right angle triangle. You got OP square by Pythagoras theorem. In this triangle, you got BP square by Pythagoras theorem. So BP is 4 root 10 centimeter. Done. Now let us look at the next one. Now look at this sum, 12 part A. Very interesting. In the figure given, AB is 8 centimeter. AB is 8 centimeter. Okay. M is the midpoint of AB. So AM will be equal to MB will be equal to 4 centimeter each. M is the midpoint, they've told. Semicircles are drawn on AB, two semicircles if you can see, with AM and MB as the diameter. A circle with center C touches all three semicircles as shown. Find the radius. Look carefully. This is the center of this semicircle P. This is the semicircle center for this semicircle. And okay, now look over here carefully how to proceed. We know, suppose this is PQ, this is R, this is S. We know one thing, that CP is a straight line. CP is a straight line. Why? Because when two circles touch each other externally or internally, their centers and the point of contact, if R is the point of contact, they lie in the same straight line, which means CP will be equal to CR plus RP. Suppose CR is small r, the radius which we need to find. So CP, CR. Now this is the radius for this semicircle. The diameter is 4. So what will be the radius? Radius is 2. So this is 2 centimeter. So 2 plus R. Done. Now PM, definitely 2 centimeter. No doubt in that. Because that's the radius. If AM is the diameter, P is the center, then PM is the radius. Now look carefully. What I'll do, just pay attention. If you look, if I proceed this line, MN is the radius for this biggest semicircle. So MN is 4 centimeter. Try to understand. For the biggest semicircle, M is the center, N is a point on the circumference. So MN is the radius, which is 4 centimeter. Now MCN is a straight line which connects the center of this circle, and the point of contact, which is N. Yes or no? So CN is the radius, which is R for this semicircle, for this circle, sorry. NC equals to R. Then what is CM? CM is 4 minus R. Quite logical. From here to here it's 4. From here to here is R. So what is this? 4 minus R. Now Pythagoras theorem. In CMP, in triangle CMP, look carefully. CP square is equal to PM square plus CM square. Substitute the value. CP 2 plus R whole square, PM 2 square, CM square 4 minus R whole square. Yes or no? Simplify this. A plus B whole square, A square plus B square plus twice AB, 4. A minus B whole square, A square plus B square minus 2AB. R square gets cancelled. So 4R plus 8R, 20 minus 4. So 12R equals to, this is how much? 16. So R is 16 by 12. That's 4 by 3, sorry, for 3 times, for 4 times, for 3 times. That's 1 by 3 centimeter. So the radius of the inner circle, which touches all the 3 semicircle, is 1 by 3 centimeter. We just need to remember that when two circles touch externally or internally, then the point of contact and the centers lie on the same straight line. Then only we can solve this sum. Done. Chalo. We'll look at number 12 part B now. Now look, a very interesting sum. 12 part B. In the figure, equal circles with center O dash and O touch each other at X. O dash is produced to meet the circle O dash at A. AC is the tangent to the circle whose center is O. Okay. O dash D is perpendicular to AC. This is perpendicular. O dash D. They've given this. Find the value of AO dash by AO and area of ADO dash by area of ACO. See, by the look of the sum, we know there's something to do with similarity, ratio of the areas, ratio of the sides. So, if you look carefully, first of all, OC will be perpendicular to AC because the radius is perpendicular to the tangent at the point of contact. Yes or no? So, this is 90 degree. Now, look at triangle AO dash D, AO dash D and AOC. ADO dash is ACO angle given 90 degree. This was given and this we know OC is perpendicular to AC by the theorem. And angle DAO dash is equal to CAO common. That's the common angle. Yes or no? Which means these two triangles, triangle AO dash D and triangle AOC, are similar. They're similar by angle property because two angles are equal. Yes or no? If two angles are equal, the third angle is equal. So if two angles are equal, we can see that the two triangles are similar. Now, if they are similar, the corresponding part of the similar triangles are proportional, which means AO dash by AO will be equal to O dash D by OC will be equal to AD by AC. And one more relation was there. I'm just writing the relation. Area of triangle AO dash D by area of triangle AOC, okay, will be equal to the square of these. We have done it earlier while doing the chapter similarity. Yes or no? Now look, the first portion they told us to find AO dash by AO. Now look, these two are equal circles. So if AO dash is, suppose X no, I'll take R. O dash X will be R and XO will be R. And AO is a straight line. AO is a straight line. Why? Because if two circles touch each other externally, then the point of contact and the centers lie on a straight line. Yes or no? So O dash is a straight line, which means AO is also a straight line. Then AO dash by AO. AO dash is R and AO is 3R. Look carefully. So 1 by 3, which means the ratio is 1 by 3. Done. Now, use this relation. Area of triangle AO dash D by area of triangle AOC, square of this AO dash by AO whole square. AO dash by AO is 1 by 3, so 1 by 3 whole square, that's 1 by 9, which means the ratio is 1:9, and over here the ratio is 1:3. Done. It was based on similarity, and again the same property that if two circles touch each other externally or internally, then the point of contact and the centers lie on the same straight line. Done? Chalo. We'll do the next part, number 30. Look at number 30. Very interesting. The length of the direct common tangent to two circles of radii 3 cm and 8 cm with the centers 13 cm apart. So, direct common tangent I've already told in my previous videos. Suppose there are two circles. Okay. Then this tangent which touches both the circle, which means this is a tangent to both the circle. This is known as your direct common tangent. And if I draw from this point to this point, that will be my transverse. This is my direct common tangent. Suppose it touches this circle at A and this at B. So we need to know the length of AB. The length of the direct common tangent to two circles of radii 3 cm and 8 cm with the centers 13 cm apart. With the centers, this is your A, O dash O, 13 cm apart. Done? Sure. We need to find AB. Simple. We need to find AB. This is the length of the common tangent. What I'll do? We know O dash A is perpendicular to AB, no doubt. because the radius is perpendicular to the tangent. OB is perpendicular to AB again. This is also 90 degree and this is also 90 degree. So what I'll do, just look carefully. From O, I'll drop a perpendicular on AO dash. From O, I'm dropping a perpendicular. OD. OD, this is my construction, is perpendicular to AO dash. Now look at the figure ABOD. ABOD. That figure is a rectangle. Why? Because see, 90 degree, and this is also 90 degree. So if three angles are 90 degree, then the fourth angle has to be 90 degree. So we can say that ABOD is a rectangle. Why? Three angles are 90 degree. So in a quadrilateral, if three angles are 90 degree, we can say it's a rectangle. Yes or no? Which means the opposite sides will be equal. So AD will be equal to BO, which is 3 centimeter. So this is 3 centimeter. OD will be equal to AB. OD equals to AB. We don't know the length of OD. Now, what is DO dash? DO dash. Look carefully. AO dash is 8. This is 3. So this is how much? 8 minus 3, that's 5. So 8 minus 3, that's 5 centimeter. This is your 5 centimeter. This is 90 degree. Though in the diagram it's looking small. Okay. So we got DO dash as 5 centimeter. Now look at the triangle DO dash O. Triangle DO dash O. This is 90 degree. By construction, OD is perpendicular. OD is perpendicular to DO dash. So this O dash is the hypotenuse of this right angle triangle. See, I'm talking about the triangle. Just a second. DO dash O. This is 90 degree. This is 5 and this is 30. Pythagoras theorem. So O dash is the hypotenuse, which means can I write 13 square, hypotenuse square is base square, which is OD, 5 square, plus OD square, I can write, which means 169 equals to 25 plus OD square. So 144 equals to OD square. So OD will be plus minus root 144. Yes or no? Pythagoras theorem, simple. Hypotenuse square is base square plus perpendicular square. Done. So OD is plus minus 12. We'll take the positive value. So OD is 12 centimeter. And we know ABOD is a rectangle, which means OD and AB is same. AB equals to OD, which is 12 centimeter, which means the length of the common tangent, direct common tangent, will be 12 centimeter. Done. There was an important construction that from O you need to drop a perpendicular on AO dash. Then this becomes a rectangle. Okay. Chalo. We'll do number 14 now. Now let us look at number 13. Actually the previous sum which we did was sum number 14. Okay, that was not 13. 13 is this. The length of the direct common tangent to two circles of radii 12 centimeter and 4 centimeter is 15 centimeter. Calculate the distance between the centers. So what happened? I'll draw two circles again. Okay, this is the direct common tangent, suppose AB. The length of the direct common tangent to two circles of the radii, the radius are 12 centimeter, and for this one it is how much? 4 centimeter. Okay, and the distance between them, the length of the tangent is 15 centimeter. We need to find this, the distance between them, O dash O. This distance we need to find. Same logic. From O, drop up. This is 90 degree. This is 90 degree. OA is perpendicular to AB, OB is perpendicular to AB. Same reason, the radius and the tangent are perpendicular to each other. From O, drop a perpendicular OD on AO dash. This is 90 degree, this is 90 degree, this is 90. Then ABOD is a rectangle, no doubt, because three of the angles are 90 degree. So fourth angle will be 90 degree. That's a rectangle, which means in rectangle opposite sides are equal. So AB and OD will be equal, 15 centimeter. 15 centimeter. AD and BO will be equal, 4 centimeter. So this is 4 centimeter. Look carefully. So what is O dash D? O dash D, this is 12. 12 minus 4, that's 8 centimeters. So this is 8 centimeter. Done? Yes or no? Now look at the triangle O dash D. O dash D. You know, look carefully. O dash D. This is 8, this is 15, this is 90 degree. So we need to find the hypotenuse. So O dash O whole square is 15 square plus 8 square. Yes or no? So O dash O whole square is 225 plus 64, 289. So O dash O is root 289 plus minus. That's plus minus 17. So O dash O is 17 centimeter, which means the centers are 17 centimeter apart. That's my sum. Okay, calculate the distance between the centers. Chal. In this video, we'll keep it till here. In the next video, we'll look at the rest of the sum. Till then, take care and be safe. And if you like the video, do subscribe and share with your friends.